Welcome to section 10.4, Secants and Tangents. Today we look at some very special segments related to circles. The first one we have is a secant. A secant is a line that intersects a circle at exactly 2 points. So you'll notice here on AB, it's a line and not just a segment. So AB, with the line symbol, is a secant line, whereas segment AB is a chord. And what's the difference? The difference is that the chord is going to stay completely within the circle, and the secant line is going to go beyond it. So the secant is going to go outside the circle here and outside the circle over there. So it's going to go and extend that chord into a secant. We have a tangent line as well. A tangent is a line that intersects a circle at exactly 1 point, and that's called the point of tangency. This line right here, AB, is our tangent line, and we also have a radius here, which is OA. The place where they intersect, point A, is called the point of tangency. So if we look at a diagram, oops, let me get over there in the right spot. There we go. This is a tangent line and a radius. You'll notice here that in this particular case, the radius and the tangent, when they intersect, are going to form right angles. Well, check out what happens. No matter where I put that radius, a line tangent to that is always going to be perpendicular. It's always going to form that 90-degree angle. That's a very important idea, and I'll say it again. A radius and a tangent are always perpendicular at the point of tangency. There we go. Now we're back. Alright, sorry about that. Alright, so what that means is then AB is a tangent line, and then a radius will always be perpendicular to the tangent no matter what. So right here at angle A, AOB or OAB, we have a right angle. So example number 1, we have that OR is equal to 25, so I'll mark that in. 25 right here. And I have that ER is 24, so mark that up. We want to find the area of circle O. So in order to do that, we have to find out what the radius of the circle is. So the first thing I'm going to do is draw in a segment that is going to be a radius that's going to be tangent to the circle here. There we go. I think that'll work. Change my arrows. There we go. Alright, so I start at O. This is my radius. And I draw it right to E. Now E is the point of tangency with the line RE, and OE is the radius. So just as we talked about here, the radius and the tangent are going to be perpendicular. So we've got a right angle right here. Oh, wait a minute. I have a triangle, a right triangle, with a hypotenuse of 25 and a leg of 24. The other leg has got to be 7. So if I want to find the area of the circle, I'm going to plug in the formula pi times 7 squared. And I get 49 pi. Notice I left my answer exact. Unless it says to round, I'm not going to. I'm going to leave it in terms of pi. Again, radius and tangent are perpendicular. Example number 2, we have concentric circles with radius 9 and 15, and we want to find the length of segment MN. Well, I want to think about this segment MN in 2 different terms. I want to think about what is it in terms of the bigger circle, and then what is it in terms of the smaller circle. So if we look at the smaller circle here, segment MN intersects at exactly one spot right here at E. Wait, OE is a radius. MN is a tangent segment. What that tells me then is that I have a radius and a tangent. They're going to form right angles. But if I think about this in terms of the bigger circle, MN is not a tangent. It's inside the circle. It's actually a chord, a segment that connects 2 parts of the circle. So we have a radius and a chord that are perpendicular. Thinking back to what we did in section 10.1, a radius and a chord that are perpendicular are going to bisect the chord. So I know that these 2 pieces are going to be the same. So the next thing I need to do is figure out, well, using the information that the radii are 9 and 15, how does that help me get what ME or EN is to help me find MN? And the trick is I've got to draw in a radius, and I'm going to draw in a radius from O to M. And that's my bigger radius, and I know that because it's the bigger circle. The smaller circle is inside the bigger circle. So I know that my radius for this one is 15. And the radius for the smaller circle, the inner circle, is 9. So wait a minute, that's a triple, 9 and 15. The missing piece here would be 12. And that segment represents ME, but I want MN. Now we already said that that chord has been bisected, so if this half is 12, then the whole thing is double that. 24. And using that idea of the radius perpendicular to a chord and also connecting what we've already done. Then we have the common tangent procedure, and this is where we'll end for the day. Our procedure is this. If it says something about a common external tangent, we want to follow this procedure. Draw both circles if necessary. Sometimes that's going to be given to us already. Then draw in both radii so that they're straight down. Makes your life a lot easier. It's a lot easier to pick out the shapes next if you draw them straight down from the top points. Draw in the common external tangent. Common meaning what they share, external meaning outside, tangent meaning touches the circles once. And then we want to draw in a segment connecting the centers, and we'll talk about how do we get that measurement a little bit later. And then step 5, you're going to have a trapezoid now. You're going to take that trapezoid and break it apart into a rectangle and a right triangle. We can easily solve rectangle and right triangle measurements. Trapezoids are a little more challenging. And then find the length of the common external tangent. Looks like a lot of work, but if you follow this procedure we're going to do next, should be in really good shape. Alright, so we have here, we want to find the centers of two circles of radius 12 and 20 that are 17 apart. We want to find the length of the common external tangent. So I'm going to draw a circle, and we'll do just a regular old circle here. There's one of my circles. And I'm going to draw another one. Okay. And what I need to do next, oops, let me get rid of that. What I need to do next is draw in the common external tangent. So that's this segment right here. And now I want to draw in the radii straight down and draw a segment connecting the centers. So I've got my trapezoid set up. Then I'm going to break that trapezoid down into a rectangle and a right triangle. So here's my right angles. And it says here the center of the two circles of radii 12 and 20 are 17 apart. That 17 represents this segment right here. The 12 and 20 are the radii. This is 12. This whole thing is 20. But wait, a rectangle, the opposite sides are equal. So this is going to be part of 12. And what's left is what's left over from 20. 20 minus 12 gives me 8. And then from there, I'm going to complete the triple. It's a right triangle. If it's not a triple, I need to use Pythagorean theorem to find the common external tangent. 15. And because opposite sides of a rectangle are the same, that's 15 as well. So that's the main idea for the section, is that we want to make sure that we have, we know what a tangent is, we have to know what a secant is, and the main idea for the